Hari Om. From this video onwards, we are going to discuss the fifth module of software engineering course. This is the first video of the fifth module. In this video, we are going to start with the introduction to software testing. Before we start with software testing, let us just recollect what are the topics we covered in the 4 different modules. In the first module, we discussed what is software engineering, what are the different terminologies used in software engineering. Then the very important topic is the software development life cycle, which we discussed in module 1. We have discussed the different software development life cycle models. We have seen what are the advantages and disadvantages of each and every model. And we have also discussed which is the very effective model for software development. The second module was dealing with the requirement engineering process, which is otherwise known as requirement analysis and specification, in which we discussed the 4 important steps of requirement engineering. Requirement elicitation, that deals with how to collect the requirements or how to gather the requirements from the different stakeholders. Then the second step, requirement analysis. How do you analyze the collected requirements? Once the requirements are collected, how do you document these requirements? Then we go for reviewing the document. Then we have discussed in the third module what is software design, the second important phase of software development life cycle. In the software design, we have discussed what are the different designs available, what are the different design strategies used, and the 2 important design approach. One is the function oriented design, the other one is object oriented design. We have discussed what are the different steps used in the function oriented design, and also we discussed what are the different notations used for the function oriented design. Then in the 4th module, we discussed the object oriented approach, in which we discussed what are the different concepts of object oriented approach and how to analyze and design the object oriented approach. Also, we discussed in the 4th module a case study based on object oriented approach, which is the library information system. How do you automate the library information system, and what are the different use cases available, and how do you design these use cases and the object oriented approach. So these are the different topics we covered so far in our software engineering course. Now, after the software design, the next phase of software development life cycle is coding, which we are not going to discuss here. Of course, you can select any one of the suitable programming language for the coding, and the design will be implemented as a program in the coding phase. So once you have completed your coding, the very important step in the software development life cycle is the software testing. So before you deliver the software product to the customer, you need to test the software on your own. The developer need to test the software before it is being delivered to the customer. So you need to follow different strategies in the software testing. If this is the case, we are going to discuss in the 5th module what do you mean by software testing, why we need to test the software, and who is responsible for doing the testing process. Also, we will talk about what are the different test cases and what do you mean by a test suite. Then we will find out the difference between verification and validation, and the different terms like what do you mean by alpha testing, what do you mean by beta testing, what is an acceptance testing. Then the two very important testing strategies, one is called as functional testing and the structural testing, that will also be discussed here. Apart from that, the testing process can be put under different levels. So we will be discussing what are the different levels of testing, right from the unit testing to the validation and acceptance testing. So these are the different topics we will be covering in the module 5. Okay. So now let us get into the topic, software testing. So as I have already told you, software testing is a very important activity, or you call it as the important phase of software development life cycle. And this is the phase which consumes significant amount of effort. So if you take only 30% of your software development duration for programming or for coding, you may have to take 25 to 40% of the duration for testing the software. So it takes a considerable amount of time and effort for testing a software. So you need proper strategy to carry out the testing systematically and effectively. This is very important. So you are not just running the software, or you are not just running the program and test the software. You need to follow a very systematic approach, and this systematic approach is what you call as a particular strategy. So you follow a strategy, then carry out the testing in a very systematic and effective manner. Only then you can deliver a high quality software product. This is very important. So if you have an effective software testing, then your product, your software product will be a quality oriented software product. So effective software testing will ultimately give you a high quality software product. That is why we need to follow, or we need to design different strategies to carry out the testing systematically and effectively. Therefore, testing strategy provides a framework or set of activities, because you need a proper strategy to do the testing. If this is the case, you need the testing strategy which will provide a framework or some kind of activities that is essential for the success of the project. So only if the customer is satisfied, or only if you deliver a high quality software product, you can say your project is a successful project. So for the success of the project, you need a very well designed framework of testing strategy, or a very well defined set of activities that will carry out testing in a systematic and an effective manner. Now, when you take software testing, you might have come across these definitions like testing is the process of demonstrating that errors which are not present. Testing is the process of demonstrating that errors are not present in your software. Or the purpose of testing is to show that a program performs its intended functions correctly. Testing is the process of establishing confidence that a program does what it is supposed to do. So these are some of the definitions you might have come across when you see what is software testing. But if you see, all these definitions are incorrect definitions when you consider a software testing. So if it is simply a testing, maybe these definitions will be appropriate. But for software testing, these are incorrect definitions. You can't say this is what you do in the software testing. Then the question is, what exactly software testing is? What do we intend to do the software testing? What is expected in the software testing? So software testing is the process of executing a program with the intent of finding errors. It is not that you are going to do the testing for not having errors. Instead, you do the testing process to find out the errors. You want to find out what are the errors, what are the bugs, what are the faults that are available in your program. That is why you are doing the software testing. So in general, you can say these are incorrect definitions, whereas testing is the process of executing a program with the intent of finding the errors in your program or in your code. Okay. So, according to the most appropriate definition, there is a fundamental entity. Errors are present within the software under test. So this cannot be the aim of software designers. So they must have designed the software with the aim of producing it with zero errors. Most of the time, the software designers will try to produce a software assuming that there are no errors in the software. So when you design or when you develop a program, say for example, you might have written lots of programs in your lab sessions. When you start writing the program, you assume that there are no errors in your program. You start typing your program, and while executing the program, you come across lots of errors in the program. So whenever you develop a software, you feel that your program is with zero errors. But when you start executing and testing, I find out lots of errors in the program. Now, when I say software testing is the process of finding the errors, if so, why we need to do the software testing? So this is another question that may arise when we discuss software testing. Although software testing is itself a very expensive activity, launching of software without testing may lead to cost potentially much higher than that of testing. So you may feel that without testing I can deliver the product, but please understand, when you deliver the product without testing, remember the maintenance cost will be much higher. So to overcome this difficulty, we always do the testing. Sorry. So in most systems, however, it is the cost factor which plays a major role. It is both the driving force and the limiting factor as well. So it is not only the cost factor or not only the error-free code, the cost is also very important. So in the software life cycle, the earlier the errors are discovered and removed, the lower is the cost of their removal. So what we do when you are doing the requirement analysis, when you review the requirements, there itself we'll start finding some errors. Then when you start designing, when you review your design, again you will find out some errors and you will be correcting it. But even though you have corrected all the errors in both the phases, in the requirement engineering as well as in the design phase, after coding you may find some errors in your program. So this must also be identified and this must also be removed from the software before you deliver the product. So the question is, why we need to test the software? First reason, errors occur at any stage during the development Probably you might have developed one module, it is error free, but when you have integrated the module with another module, errors may occur. After integrating the modules, you may try to give some database access. By the time, errors may occur. So errors occur at any stage during the development. So though detected after each phase, some errors remain undetected that are reflected in the code. This is what I mentioned here. Though you have identified the errors in the requirements review as well as in the design review, it may not be enough for delivering the product as such. You have to some of the errors remain undetected even after each phase of the software development, and these errors will be reflecting in the software code. So the final code is likely to have some requirements errors may be there, design errors may be there, in addition to errors during the coding activity. So when you do the coding process, you may have some errors. So in addition to these errors, even though you have detected the errors after each and every phase, some requirement errors and some design errors will appear in the software product. So to ensure the quality of the software, these defects or the errors that you have identified must be removed from the software before you deliver it to the customer. If so, there are two types of approaches for identifying defects in software. One is called as static approach, the other one is called as dynamic approach. So in the static analysis, what you are going to do, the code will not be executed, but it is evaluated through some process or some tools for locating the defects. Something like code inspections. So you will be going through statement by statement or code by code or function by function or declaration by declaration, like that. You will be doing code inspections manually, or you may be using some software tools for the code inspections. That is what you do in the static analysis. So the program will not be executed, but you trace each and every statement of the program and you test whether any errors are available or any defects are there in the program code. But on the other hand, in dynamic analysis, code will be executed and the execution is used for determining the defects. So you start executing your program, give the valid inputs, give the invalid inputs, and then you check whether any defects or errors are there in your program. So these are the two types of approaches that we will be following when we do the software testing. Now, whenever you have a software which is used for testing, you call the software as SUT. SUT is nothing but the software under test. So whichever software you are testing, that is called as SUT or software under test. The software will be tested with set of test cases. All the sort of test cases you will be writing for each test case. When I say test case, you will give some valid inputs, you will give some invalid inputs, you will start executing the program with set of valid inputs, then with set of invalid inputs, and you will find out whether it is giving you the expected output, whether it is executing all the instructions, whether it is giving you the intended output. All these things will be done in the software testing. Now, when you are going to test the software, behavior of the system for these test cases will be evaluated. So when I give a valid input, how your system is responding. When I give an invalid input, how your system is responding. That is what you call as behavior of the system. Then you will determine if the system is performing as expected. So what you are going to do, the software is tested with a set of test cases. By the time behavior of the system for these test cases will be evaluated, then you determine whether the system is performing as expected. So what you do, I write some test cases, say test case 1 with valid input, test case 2 with invalid input. Imagine you have a login form. In the login form, you give the username and password. So you want to do the testing now. So what kind of testing you will be doing? First you try giving a valid input, valid username and a valid password. After giving this test case, you will be evaluating the behavior of the system. So when I click the login button with valid username and valid password, whether the system is taking you to the next page. That is what you are going to evaluate. So if it is taking you to the next page, then you say the system is performing as expected. Or on the other hand, what you do? In the login form, you try to give the correct username but wrong password. When you click the login button, what happens? That is what you call as behavior of the system. Or you give a wrong username and a wrong password and you check whether the system is performing as expected. Or when you click the forget password link, whether it is taking you to the next page what you have expected to do. So this is what you call as software is tested with a set of test cases. By the time the behavior of the system for these test cases will be evaluated, then determine if the system is performing as expected. So that is what you mean by what is software testing and why software is being tested. Now the next question is, we have seen what is testing, we have seen why we are doing the testing. Now the next question is, who is responsible for doing the testing process? So testing requires the developers to find errors from their software. So I have developed a module, I have to find out some error. But remember, it is very difficult for software developer to point out errors from their own creation. So I have developed a software. So I am with full confidence saying that yes, my software is working properly. Right? So no software developer will be ready to accept that, oh, my software is having some errors. So it is very difficult for the software developer to point out some errors from their own creations. So what the many software organizations will do, they will have distinction between development and testing. So they will have different teams. One team will be doing the development process, the other team will be doing the testing process. So if A, B, C are developing the software, then D, E, F will be testing the software. So the developer or the programmer who has written a particular module or a particular unit will not be testing the software. Instead, it will be given to another team which will be doing the software testing. So this particular point we have to remember, because this is going to give an additional advantage. Faced with the opportunity of testing someone else's software, our professional pride will demand that we achieve success. So success in testing is finding errors. This is very, very important. See, A has developed a module. That is his role. A's role is writing a program. If this program is given to D, what D has to do? D has to find out some error. So what is the duty of D here? Somehow or other he has to find out the error from the module that is developed by A. So this point you have to understand here. So obviously D will be running the program upside down to find out some kind of errors. That is why many software organizations have made a distinction between development and testing phase. How? By making different people responsible for each phase. So development phase will be done by one group, whereas testing will be done by another group. So this is how the testing will be done. Now the next question is, we have seen what is software testing. Then we have seen why we have to do the software testing. Next we have seen who is responsible for doing the testing. Now the last one is what you are going to test in your software. What are we supposed to test in the software that we have developed. So what you are going to do, you are going to test the program's responses to every possible input. That means you are going to test for all valid and invalid inputs. Fine. I'll give you an example here. Suppose a program requires two 8-bit integers as inputs. Total possible combinations are 2 power 8 into 2 power 8. Imagine if only 1 second is required to execute one set of inputs, it may take 18 hours to test all the combinations. If considered invalid inputs, many more combinations are possible. This is only for the valid inputs. If I have 8 bits, 2 power 8 values are there. If I am going to have two 8 bits, 2 power 8 into 2 power 8 combinations will be available. So all these data must be tested for the valid inputs, and imagine how many invalid inputs we are going to have. So all these things you need to test. Not only that, another possibility is you are going to execute all the possible parts of the program. Now when I say possible parts of the program, imagine if you have a if statement. You might have given a statement like if A greater than B, then true part will be there. Else you will have a false part. So imagine when you are writing the program, you have a condition, and for the condition you have a true part of the program and you have a false part of the program. So when you test, what you have to do, you have to give a true case and you have to give a false case also. So there are two parts for that particular if condition. So that must be executed. So imagine if your program is a lengthier program or a long program with thousands and thousands of lines of code. Imagine how many possible paths will be there. And if your program contains lots of branching, obviously your program will have many paths for execution. So what you are going to do, you have to start from the program till the program gets terminated. You have to find out all the possible paths for your program. And your program will have many paths for execution. So the conclusion here is the complete or exhaustive testing is not just possible. So imagine I have given you an example here of two 8-bit integers. Imagine if you have 5 32-bit integers in your program, how much time it will take for the testing. And if your program is having 1000 lines of codes with minimum 8 to 9 branching, then imagine how many possible paths will be available in your program. So therefore, the complete or exhaustive testing is not just possible. So what you have to do, you are going to test those areas where probability of getting an error or fault is maximum. So only those areas you are going to identify, and only those areas you are going to test with proper strategies that we are going to use in the software testing. Okay, so that's it about the introduction to software testing. We have seen what is a software testing and why we need to test a software, who is responsible for testing a software, and what we have supposed to test in a software. And we have come to a conclusion that whatever testing you are going to do, the complete or exhaustive testing is not just possible. So you need to follow proper strategies for a systematic testing to the areas where probability of getting an error or fault is maximum. Now next we will be talking about what are the different terminologies that we are using in the software testing. Let us see the different terminologies in the next video. Thank you.